attracted by magnet. Basically, we know the fact when two same poles are forced together, it will repel, and while two different poles are forced together, it will attract to one and another. Then, we must know that electromagnet only happen when electric current flow through the wire. Next, the magnetic field strength of electromagnet can be increased by increasing the current through the wire or increased by the loop of coil. Fleming's left-hand rule is used to find the direction of the force acting on the current carrying conductor placed in a magnetic field. So this is the video explanation about how to use Fleming's left-hand rule in this experiment.
Using Fleming's left-hand rule to help us remember how current, magnetic fields, and direction all go together. First, let's talk about the motor effect. A wire carrying a current creates a magnetic field. This can interact with other magnetic fields, causing a force that pushes the wire at right angles. This is called the motor effect. So magnetic field from north to south, the current going this way, and the force at right angles. We can use our left hand to help us remember what direction the wire is going to be pushed in. It's called Fleming's left-hand rule. With your left hand, spread out your thumb, first finger and second finger, so they are all at 90 degrees to one another. Your first finger represents the direction of the magnetic field, from north to south, so your finger is pointing to the south pole. Your second finger represents the direction of the electric current, flowing from positive to negative, so your finger is pointing to the negative. Your thumb represents the direction of movement. Try to remember it this way: thumb, movement. First finger, magnetic field. Second finger, current.
This is block diagram of simple motor.
Source: electrical power source is needed to drive electric motor. In our country, 230 volt 50 Hz is used for single phase and 415 volt 50 Hz is used for the three-phase power source, where the DC power source is using for the DC system. Power modulator can be used to control output power of the supply. The power controlling of the motor can be done in such a way that the electric motor sends out the speed torque figure, which is the necessary with the load. Motor use depends upon many factors like characteristic of load, whether the speed control is required or not. If required, whether continuous control is needed or 2 to 3 fixed speeds are needed. Load can be decided by environment of the industrial process, and the power source can be decided by an available source at the place. Sensing unit. The block diagram is used to sense the particular drive factors such as speed, motor current. This unit is mainly used for the operation of the closed loop, otherwise its protections. Control units used to control the power modulator, and this modulator can be operated at power level as well as small voltage, and it also works at the power modulator as preferred.
We are using this simulation to see how magnetic force acting on current carrying wires can be used to drive an electric motor. Video of simulation.
In a DC, direct current, motor, a permanent magnet is used to push on current-carrying wire. When an electric current is placed in a magnetic field, it experiences a force perpendicular to its motion. A commutator allows the current to be turned on and off rhythmically, so that the loop can build and maintain momentum. Adding more wires increases the force, but at the expense of adding electrical resistance and self-inductance to the circuit. Let's play around.
which allows you to change the type of input voltage for alternating current AC to direct current DC. This slider adjusts the current in the motor, and the amount of force depends on both the number and velocity of the electron in the wire. This slider adjusts the size and strength of the permanent magnet used to exert a force on the wire. This slider adjusts the length of the motor and therefore the size of the motor. Fleming left-hand rule is used in electric motor, which are F for force, B for magnetic field, and I for current. This slider adjusts the radius of the motor and therefore the size of the motor overall.
Project benefits: high efficiency. Electric motors do not use fuel and they do not require engine oil maintenance like most of the other electrical devices. Low initial costs. Electric motors have very low initial costs and very charismatic to use for a long time. Durability. Electric motors contain a few moving parts and they operate smoothly with increased their lifespan. Reduce noise pollution. Electric motors are capable of providing smooth drive with the highest acceleration over the longer distances. Eco-friendly. It does not emit toxic gases or smoke in the environment. Lowest electricity. That means the lowest carbon emission from the manufacturing and from the end of life is the best option for the zero carbon customer. At the end of this project, we had learned how magnetic field forces acting on current carrying wires can be used to drive an electric motor using the simulation. In summary, when current runs through the circuit, a force will be exerted on the wire. An electrical motor changes electrical energy into mechanical energy. A split ring commutator keeps the current in the coil flowing in the same direction even though the coil changes sides every half turn.